My name is Jay Austin. I am a professor in the Department of Physics and Astronomy and the Large Lakes Observatory at the University of Minnesota, Duluth. We are on the deck of the Blue Heron, which is a research vessel owned by the University of Minnesota. It's the largest academic research vessel in the Great Lakes. We are currently in the western arm of Lake Superior, on our way home after successfully deploying a pair of meteorology buoys and collecting some stuff that we left in the lake last winter. So the buoys that we dropped off this morning are there to measure surface meteorology primarily. And so we're measuring things like wind speed and direction and air temperature and humidity. We measure the amount of sunlight and infrared radiation coming from the atmosphere because we're interested in how the lake interacts with the atmosphere. These two buoys also had instruments called thermistor strings, which measure temperature not just at the surface, but at multiple depths through the water column. The buoys are in about 52 meters of water, so 160, 170 feet, relatively shallow for Lake Superior. The deepest deployment that our lab has done was in the deep water in the southeastern portion of the lake, and that was in 384 meters, which is getting on towards 1,500 feet deep. Yeah, that takes a long time to deploy. So it's a lot of cable. One of the long-term things I'd like to do is think a little bit more. There's been a lot of descriptive work done on upwelling in the Great Lakes, far less actual sort of dynamic, developing fundamental understanding. And so we have a nice pair of buoys here, one relatively near shore and one offshore. I feel like this is an ideal test bed for developing a better understanding of coastal upwelling. And so the basic idea behind upwelling, as long as we're on the topic, is that alongshore winds, and it's sort of weird that it's alongshore winds, but alongshore winds can cause that warm surface layer to move offshore. And when it does so, cooler water from below will come and replace it at the surface. And so if you're a swimmer in Duluth in July or August, if the wind blows from the right direction, the water's not swimmable anymore. And then go and talk to the kayakers we have on board. They know a lot about upwelling because it goes from being uncomfortable to life-threatening if you fall in the water at that stage. So Jessica Rogers is a colleague of mine in physics and astronomy. She is the director of the planetarium here on campus, and she's a great science educator. And so I asked her to join on this project. And the idea is that we are going to take data from these buoys or similar data and package it in such a way that someone in a 9 through 12 classroom can use them to teach a lesson either about how to work with data or teach a lesson about how lakes work, right? And the idea is that having students working with real data as opposed to something that they could relate to will make it a more immediate experience. Like, oh, this is data from a buoy collected yesterday. Oh, and look, we can see that it was cold yesterday, wasn't it? And look, you can see that it's cold. So the idea is just to develop a handful of basic 9 through 12 lessons based around our buoy program. We are going to be bringing in and workshopping with local educators to see what works and what doesn't, since I'm certainly not a K-12 educator, right? And so I want to make sure that when we do things, it's actually useful to classroom educators. And I'm hoping to work closely with Sea Grant in developing those connections. I've been here since 2005, so getting on towards 20 years now. I've probably overseen, 50, 60, 70 deployments. Of those, I think we've had 2 failures where we didn't get stuff back, and that's obviously really disappointing, but it's also a reasonably good track record. We distribute the data in real time, or near real time, to a federal organization called the National Data Buoy Center, which coordinates buoy data from around the global ocean. We also send our data to a group called the Great Lakes Observing System, or GLOS, which maintains a really, really comprehensive array of Great Lakes data sources. Our main sort of federal professional user is the National Weather Service. And so I meet with them and take suggestions about what sort of things they'd like to see added to the buoys, something we're going to be doing this year. And they use that data to improve their ability to forecast marine weather, which basically equates to marine safety, right? If it's wavy out, you don't want to be out here. We run a local website, d.umn.edu/buoys, that provides this data in near real time, provides profiles of water temperature, provides surface meteorology, waves, a map of regional winds, those sorts of things. I would love to work with Sea Grant to continue to expand our audience for these sorts of things. I think that's something that Sea Grant would excel at. We have a couple of people riding with us today who are inveterate paddlers in the lake, and they log on all the time to look at the data that we have. And so I would like to understand better is understanding who it is that's using this data on a daily basis. I know a lot of people have come up to me and say, oh, we run the buoys. Yeah, we look at that all the time. That's really exciting to me, that there are people, in the community that maybe not rely on the data, but certainly are interested in it.